Hello ladies and gents, welcome to this webinar where we'll be introducing some of the highlights of DesignBuilder's new version 6 functionality, and also we'll try and give you some top tips for getting the most out of the software. Most of this webinar will be focused on showing you the new tools in the DesignBuilder interface, and we'll take some time to answer any questions you may have at the end. We expect the webinar to last around an hour with some time for questions at the end. You can submit questions at any point via the question box in the GoToWebinar control panel. We are recording the webinar, so you can access it later if you want to recap on anything you see or hear today. You should receive an email with a link to the recording in about 24 hours from now. Okay, there are far too many new in version 6 to discuss them all, so our focus today will be on the functionality that is summarized here. We'll show what we feel are likely to be the items of most interest in the DesignBuilder interface, so you get a better feel for them than simply using slides. Note that we want to show how you can quickly edit multiple items of model data in the Model Data Grid View tool. But we've left the new modeler functionality to the end of the webinar, so we don't remove simulation results that we've stored in the model we'll be using today. UK and Ireland customers, please note that we expect to release an approved version for V6 in the near future, and we'll notify you once approval is confirmed. Until then, please continue to use the current approved version for certification work. Because this webinar is primarily an overview of the latest tools to help you get the most from the new V6 software, rather than a full introduction to DesignBuilder, I won't show you how to create the model geometry, so I've got more time to focus on showing you the main new features. There are plenty of free tutorials and webinars available on our website if you aren't familiar with DesignBuilder and want to find out more about how models are created. Okay, I'll start by taking a quick look at the model that we're going to use today. It's a 4-story education building on a multi-level site with some architecturally interesting geometry. Regarding the HVAC system, it has trigeneration with ice thermal storage and also mixed mode natural ventilation. We've chosen this particular system to illustrate some of the new HVAC components today. As you can see from the icon at the top right of the screen, this model is currently in the Energy Plus analysis mode for those of you who may be using certification modes. Now let's take a look at some of the key points regarding the new functionality. So daylight distribution maps have been improved and now include an option to display grid cell values and a range of color palettes. Radiance illuminance simulations are now running parallel, and that can significantly reduce the wait times for larger models. In a medium-sized model like the one you just saw, daylight illuminance results are now ready in just a few minutes, even with high-quality settings. There's a new option to define the extent of the ground plane, and this means that you no longer have to specifically add ground component blocks to accurately include the effects of ground reflected light. There's a new option to control randomness in radiance results. In previous versions of DesignBuilder, the Monte Carlo random sampling method was used, and that resulted in small variations between each calculation, even if the inputs were identical. This can make it more difficult to compare results from one design iteration to another. So we've introduced this new option to control randomness, and by default, results will now be consistent between runs for the same set of inputs. You can, of course, revert back to earlier behavior by deselecting that option. With version 6, you can store results for multiple types of daylighting simulations. So, for example, you could also include results for BREEAM and LEED analyses in the same model. We'll now take a look at some of the new daylighting functionality in the design. So I'll switch tab and I'll navigate to the have some results generated for that block. You can see here. Navigating to classrooms 1 to within each grid cell. Here we're displaying daylight factor, but we could equally display illuminance values, as you can see there. This can help in cases where a more detailed view of is different depending on your preferred style. The default is clear. Are also annual. Okay, now back to the slides just to discuss the new simulation functionality. Energy Plus version 8.9 is now the main version. You can still choose Energy Plus version 8.6 from the program options dialog, but in general, we would recommend using the default option. DesignBuilder now includes an option to model phase change materials with hysteresis for more accurate modeling. This can be important as PCM melting and freezing processes typically follow different curves, representing an effect that is commonly seen in actual building envelope phase change material applications. The new option also allows the characteristic properties of the processes to be entered instead of a detailed temperature enthalpy curve. And that makes it more amenable for studies where the user doesn't have the detailed data required to generate the temperature enthalpy curve. Multiple year simulations improve accuracy for very high mass cases such as ground domains and heat exchangers, and we'll talk more about that shortly. The updated results viewer includes options to view results as histograms and can also display results for multi-year simulations. Improved heating and cooling system design summary outputs, including fabric, ventilation, and gains data. So let's now take a look at the new multi-year simulation option, the results viewer, and the heating and cooling design improvements in the DesignBuilder interface. First, we'll go to the simulation screen and to the calculation options dialog here. So this new option enables you to run a simulation for multiple years. This can be really important for simulation accuracy when working with models where there is very heavy thermal mass included that may affect the performance of a building. A typical example is when modeling 2D ground domains, where the thermal mass of the ground itself is simulated in detail. Similarly, when simulating a ground heat exchanger, it can take several years for the ground temperature fields to stabilize to periodic steady state. Another potential application is for buildings with very heavy exposed mass concrete or stone walls, where it's important to ensure that the simulation start conditions are well represented. We didn't simulate multiple years for this model, but I do have a set of results stored for another model. So I now go back to the simulation manager. And I'm going to load the full horizontal slab insulation plus 2 meter insulation depth, 5 years. Simple with an insulated slab ground domain which was simulated over 5 consecutive years. So I'll add the surface inside conduction heat transfer rate for the ground floor and also the boiler gas rate to illustrate the main outputs that are different for each year. You can see in the results set the monthly results plotted for each of the 5 years from 2002 to 2006. You can also see that the shape of the two curves is quite different in the first couple of months. But the results have more or less converged after 3 years, though 5 or more years may be needed for complete convergence. This illustrates an important point about working with Energy Plus ground domains, that running a standard 1-year annual simulation may not be enough for best accuracy. We'll now take a look at the new results viewer histograms. So going back to the simulation manager, which holds other previously calculated result sets, I'll open an annual result set for model. And we'll take a look at the new options to view the Energy Plus summary table data as histograms. So the summary data tab here will be familiar to of summary tabular results. The most can now be visualized graphically in histogram form here on the summary charts tab. At the top left, we can select from a range of the most common tables to view them graphically. The default end uses chart that you can see here summarizes energy and water consumption broken down by end use in histogram form. There are controls to show or hide totals and empty data entries. I'll uncheck the Show Totals option to hide the total end use data. We'll now take a look at the Electric Loads Satisfied table, which summarizes the electricity generated from various sources. Here the only source is from the trigeneration system. You can see from the electricity coming from utility column that 27% electricity was drawn from the grid over the year, and that there was a 65% surplus exported to the grid. So the net effect was a 38% surplus of electricity. The zone summary gives a useful graphical overview of some key model inputs for each zone, including floor area, volume, zone multiplier, internal gains, which are broken down as plug and process and lighting, and also fresh air. Because there are rather a lot of zones in this model, it helps to zoom in for each zone more clearly. When zoomed in, we can scroll horizontally to see data for all zones. To remove the zone, finally, a look at the zone sensible cooling results. These summarise calculated design loads with and without outdoor conditions at the time of peak conditions and humidity conditions. We'll now move on to discuss the new heating and cooling system design summary outputs. But before I do that, I'd like to point out an important change to the DesignBuilder interface for those that haven't yet noticed it. In earlier version releases, mechanical and natural ventilation sizing options were set in the heating design calculation options dialog, but they're now set in the HVAC tab. Let's take a look at this here in the HVAC tab. Before we go into that, I should mention that learning mode is switched off in this model. Hence, the info panel on the right has been replaced by the model data input tabs. This can be really useful as it allows us to see the model data and the graphical representation side by side. So going back to the HVAC tab under the heating header, sizing zone equipment. When mechanical and natural ventilation are switched on, you'll see the heating sizing options for each under the relevant sizing zone equipment header. And that enables you to set the relevant sizing options, such as including or excluding heat recovery. Note the green text indicating that these inputs are only used for heating design calculations. You should ensure that they are correctly set up as part of the HVAC system before running these calculations. So having noted those points, we'll now take a quick look at the new cooling system design summary outputs. Additional at the time of maximum sensible cooling load. The new fields include gains from walls, floors, roof and ceilings, ventilation and infiltration, and from equipment, lighting, people, and solar gains. These outputs can provide a helpful indication as to where the main gains are coming from at the time of maximum sensible load, and could help guide strategies for reducing the gains in future design iterations. I'll now switch back to the slides to HVAC. So first we have combined heat and power with options for internal combustion engine and micro turbine configurations. Trigeneration is now possible by combining generators with absorption chillers. Isothermal storage and additional plant operation schemes allow off-peak electricity to charge thermal stores. Variable speed cooling towers and a new built-in curve generator tool allows curves to be quickly added to models based on manufacturer's data. So I'll now take a look at some of the new HVAC features in the DesignBuilder interface. So navigating first to the HVAC system level, you can see a view of the overall tri-generation HVAC system, also known as combined cooling, heating and power, or CCHP, with ice thermal storage. As well as generating electricity, the micro turbine with backup from a gas boiler provides heat to the supply side of the hot water loop, which feeds the fan core unit hot water coil, the domestic or service hot water tank, and the hot water connection of the absorption chiller. In this model, the generator runs constantly to generate electricity with heat as a byproduct. Alternative scenarios can also be modelled where heat is generated to meet hot water loads as the main priority and electricity is the byproduct. The absorption chiller is powered by the hot water supplied by the generator with boiler backup and supplies an ice thermal store. The overall system allows the facility to minimise the use of electricity with very low maximum loads. I'll navigate to the generator now. Open up so we can see the data that drives the simulations. There are two types of generator and internal combustion engine. This model uses a microturbine system which is configured to be available for operation 24/7. On the electric load center dialog, which I won't show today, the system is set up to use the base load operation scheme, which means that electricity is generated as the priority and heat is considered to be the byproduct. A range of alternative electric generation options are provided, including follow thermal, which allows the generator to be used primarily as a heat generator with electricity generation as a byproduct. Towards the top of the document are settings related to electricity generation, reference power outputs, a curve to correct for inlet temperature and elevation, for example, followed by various settings for fuel type, electricity efficiency, exchange. Sensitive help can be obtained by pressing the help button at the bottom of the screen there. So on the ice thermal storage side, this system is set up with a series configuration with the chiller upstream. I can show you how that is set up in the help. As an aside, the fastest way to find information in the help is to open the search function. Here I'll type in ice thermal storage to find the topic. And choose relevant option. Page, we can find advice on typical configurations. This is the setup used for this education building model, this 4-component set point. A simpler but less flexible option is the 5 thermal energy storage configuration, where Energy Plus sets up the necessary set point managers internally. Okay, moving on now to the latest features for optimization. There are 3 powerful new types of custom variable that have been added to V6 that allow you to take far greater control of the parametric variations applied to the model as part of optimization, uncertainty, and sensitivity analyses. Custom EMS is where EMS variables can be parametrically adjusted by the optimizer. Custom IDF, you can use scripting to override DesignBuilder auto-generated IDF, and custom script. C# or Python scripts can be called at specific calling points. I'll say more about what you can do with these new variable types in more detail in the slides that follow. Additional outputs can be included alongside objective and constraint KPIs to enable more in-depth post-process analysis. A new building rotation design variable is provided to complement the existing site orientation. This allows you to test for a range of building rotations relative to any fixed site objects such as other buildings, trees, etc. In this way, DesignBuilder can help you find the optimal building rotation for your model, taking into account all of the other possible design variations that you define. As a little tip for you, when using this variable, you should check before the optimization runs that the building objects can rotate freely for all of the angles that you want to test without intersecting with or clashing with site objects. If that happens during the optimization, an error will occur. Here's the first of the 3 new variable types, EMS type. This slide shows a really simple example EMS script that illustrates how to find the overall best start time for switching on the heating system. It uses a single variable value that is fed into the script by the optimizer using the var keyword default value syntax. The keyword matches with a corresponding keyword in the variables dialog. Here are optimization results for a simple model that uses the script you just saw. This illustrates how earlier heating times reduce discomfort at the expense of increased CO2 emissions. The same method could be used to applied to a more sophisticated optimum start EMS script. An example is provided with DesignBuilder to optimize the optimum start controller settings. This technique can, of course, be extended to any EMS runtime scripts, and that allows you to find optimal settings for your own HVAC and facade system controllers. So you can not only provide your own HVAC and facade systems using EMS, but you can now also optimize them. Some script variables allow you to automatically apply variations to the model using your own scripts. This allows complex changes to be made that could not be applied using the standard variable types. You could, for example, define your own extensive set of energy conservation measures and apply them by loading templates, setting attributes across the model, and even making changes to the glazing configuration. You have full access to the model through an API which exposes the same methods available to the DesignBuilder developers. Here's an example custom script that modifies the zone heating temperature in each zone. Okay, moving on now to enhanced extensibility. So we've introduced an API for plugins and scripts that allows an unlimited range of custom calculations, reports, and model processing to be added by users and third-party developers. So you could, for example, write your own code compliance tools based on DesignBuilder models. Normally, you would consider using plugins for larger applications where a number of source files are needed, and it would be more appropriate to compile source code to DLL form, or where you need to be able to update the DesignBuilder user interface to offer new menu options to act on specific user commands such as run special calculation X or update model for code requirements Y. Scripts, on the other hand, are more appropriate when code is simpler and only needs to be called at one of the pre-defined program hook points, such as before or after simulation. The same API is available for both scripting and plugins. Python scripting enables simulation inputs and outputs to be automatically processed before and after simulations based on scripts that you write. The API will be added to Python scripting later in the year. This slide shows a simple as it gets example Python script that modifies the Energy Plus IDF input file using the EPI scripting tool. The script modifies the IDF people object for all zones with dynamic clothing in the name to apply the ASHRAE 55 rule so that occupants dress according to conditions for a more realistic assessment of comfort. It also adds an extra output to allow us to view the ASHRAE 55 comfort outputs in the results viewer after the simulation. This provides a quick and relatively easy way to override default behavior and implement options and systems not yet supported by DesignBuilder. The same approach can be used in C# scripts using the EPNet tool for users who prefer to use Microsoft-based programming languages. Very briefly discuss the uncertainty and sensitivity analysis tools as we're planning a webinar dedicated to this topic in the weeks ahead. For those of you unfamiliar with uncertainty and sensitivity analysis, uncertainty analysis reports confidence levels in simulation outputs based on uncertainties in specific inputs. Sensitivity analysis reports on the design variables having the greatest impact on your key simulation results. Some typical example applications for uncertainty and sensitivity analysis are quantifying the variation in outputs alongside corresponding changes in inputs, providing stakeholders with a preliminary risk assessment on meeting design objectives, reducing the optimization simulation time by identifying any unimportant variables and excluding them from the optimization search space, and identifying aspects of the building which have a high probability of creating operation stage performance issues, and thereby helping the model calibration process. Looking now at the bullet points on the slide, uncertainty and sensitivity analysis results are presented as histograms with summary statistics and clear descriptions to aid interpretation. Sensitivity analysis is undertaken using multivariate linear regression. Regression parameters and standardized coefficients are calculated for every output variable. And input design variable sampling is based on probability distribution curves. More than 20 discrete and continuous distributions are available for selection and customization. That's all I'm going to say today on this particular topic, so please keep an eye out for the newsletter soon regarding the optimization, uncertainty and sensitivity analysis webinar. We'll now cover what we feel are the most important of the new modeler tools. As we mentioned a while back, there's been a significant increase in the number of requests we received from you to improve functionality like QA checking, interoperability, and visualization of simulation outputs. The result of that is the modeler functionality we're about to show you that builds on the improvements released last year. And these included the ability to import facade drawings, selective ghosting of blocks, a new way to show building surfaces, zones and blocks in the context of the rest of the building, and a really useful new QA checking tool. If you're not yet familiar with those tools, they're covered in the version 5.5 webinar, which you can access from the DesignBuilder website. The main new modeler functionality released with version 6 is the graphical display of all constructions and glazing used in the model, graphical display of calculated natural ventilation airflows, representation of surface edges in rendered visualisations, site and building rotation, and that's now handled within the modeler, allowing building geometry to be rotated accurately relative to the site. For those of you working with the IDF input file, please review the help item on this. The model data grid tool has been updated and now allows the data to be edited, and there's a plugin for Revit 2019. So now let's take a look at some of these in the DesignBuilder interface. We'll now take a look at some of the new data visualization tools and graphical display of constructions and glazing within DesignBuilder. So I'm at building level, and if I go to the visualize screen, you can see that this model data tab is the default view. And this allows you to see which construction and glazing systems have been applied to all of the surfaces in the model. So at building level, you can see the systems that make up the thermal envelope, and at block and zone level, you can perhaps a neater way to show section cut tool. So all of these extra visualization tools should make QA checking faster, as you no longer need to set up specific material colors to visualize, and DesignBuilder displays the information automatically. Staying in the visualization screen, but now going to the rendered view tab, we'll take a look at the how surface edges are now represented in rendered visualizations. Okay, so zooming in a little, you can see how the edges of the surfaces now have black lines, and that helps to distinguish individual surfaces from each other. This can be especially useful when surfaces have the same colours, such as the internal views, and for ASHRAE 90.1 baseline models where surfaces often have the same colour. So I'll now show you the new graphical way to display calculated natural ventilation airflows. This model already has some natural ventilation results saved. So here in the simulation screen, and if we go to the data visualization tab that was added in version 5, and we can now select additional outputs such as NatVent airflow vectors, and we can visualize them. So if I zoom in a touch here, you can see that these vectors graphically show the airflow in and out. You can also see the airflow rates represented on the surface there, and these are all represented for the time that's set in the display options. Note that generating surface and opening outputs like this creates lots of data, so it can significantly slow down simulations. Custom outputs should generally only really be used for small models or for QA testing larger models. For large models, it is advisable to switch this option off unless you're QA testing. So if I am at building level and go back to the edit screen, we're now going to take a look at the model data grid view. And these tools can now be used to view, edit, export and import the data in the open model managed in the normal way via the edit tab at site level. The grid provides a global view of data across the whole model and makes it easier to compare settings for different parts of the model than searching through various model data input tabs at different levels. The tool also allows you to export the model data to a spreadsheet if you prefer to edit the data that way, perhaps copying and pasting data from other models you've created in the past, or maybe using it as a way to import data from another tool. Once you've done that, you can re-import the spreadsheet and the model data will be updated accordingly. The tool is also ideal for bulk editing of data and for speeding up your QA processes. So when you first open the tool, after selecting one or more of the layouts you can see here, you can choose whether to view only or to edit the data. So for this example, I'm going to select the zone natural ventilation scheduled layout, and I'll use the edit option. The edit checkbox at the top left of the data grid dialog enables you to switch between edit and view only modes. The grid view follows DesignBuilder's data inheritance rules. So inherited data is shown in blue and non-inherited data is flagged up in red, as you can see here. DesignBuilder's data hierarchy and inheritance mechanisms are a great productivity strength. This tool really complements and works with data inheritance by allowing you to work at a single level across all inputs. What you see in the grid will depend on which analysis mode you're in. So you will see different things, for example, depending on whether you're in Energy Plus mode, or for those using certification mode such as SBEM or DSM in the UK, you would see something a little different, relevant to the model data for the mode that you're in. Scrolling across the grid, we can review the all of the relevant data fields. But we'll now take a quick look and see how we can use the filter tool to edit the data in bulk. I'll first go to the HVAC operation schedule header. And I'll select all classroom zones using the schedule listed D1 Edu classroom occupancy. And there we go. Okay. And you can see now that the data has been filtered down to only those that particular type of activity. So now if I want to bulk edit the data, I need to first select the desired rows, and you can do that in the normal way by selecting one row, pressing and holding the shift key, and then selecting the other rows that you want to include. And once I've selected the relevant rows, I need to click on the bulk edit option. And I can then, in this case, I'll change the flow rate. Okay, I'm going to change the flow rate from 5 air changes to 6 air changes. I only need to input the value into one cell, and all of the other cells in the rows that I've selected, the same cells will update automatically. And the cells that have been changed are denoted in blue, as you can see here, so that makes it very easy to see which data you've changed. And you could, if you wanted to, edit a number of different cells. And once you've done that and you've checked the changes that you've made, you can then confirm them using this apply button up on the top right. Okay, and that's now applied those updated settings to the model. Okay, if we wanted to group the zones according to any of the headers, we can easily do that. So let's use the minimum fresh air as an example. And I can simply drag that up from the column header into the grouping box at the top, and then the data's reordered accordingly. Okay, I'm now going to go back to the edit screen. Nice little small, there's a number of smaller improvements, but there's a nice little one that I'd like to show you right now. So here we can use the mouse wheel to zoom in and out from the point where the cursor is positioned, whereas before it didn't used to do that. So if I want to, for example, zoom in on this little section, this surface that's protruding from the curved surface there, I'd position the cursor on that and then just use the mouse wheel to scroll in. So rather than having to zoom and pan, you can now very quickly and easily zoom right into the point of interest. So hopefully you can see that these new V6 modeler and data visualization features are a really useful complementary addition to those we released last year in version 5. Going the slides, there is a DesignBuilder plugin for the most recent versions of Revit, which can help to ease the workflow when transferring BIM models from Revit to DesignBuilder. This is installed with DesignBuilder, so if the version of Revit you wish to use is installed at the time you install DesignBuilder, then it will be automatically enabled. If you install Revit later, you can install the relevant Revit plugin from our software downloads page. So thanks for listening today. That's the end of our formal presentation.